Welcome to my library. My name is Sue and I am a librarian. I have been following the work on hypothesis testing and wondered if you can help me. But first, I should point out that all maths teachers have special powers. You have previously seen Mr. Gale prove, beyond doubt, his psychic powers. Now I know Mr. Malkin has questioned this, but 7 out of 8 is not guesswork. Now my issue today is that I have introduced a new filing system in the library, and I want to investigate if the proportion of books returned late has changed. Now last year, the proportion was 0.2. I plan to investigate this with a sample of 30 books. Now another maths teacher with special powers is Mr. Skeen. Now I asked him, but he started talking about this being a two-tailed test. Before you work through the example with him, look at the question in your PDF file and think about why he is referring to a two-tailed test and what difference this makes.
Right, thank you, Sue. So if you think you can have a go at this question in the usual way, have a go, and then come back and just sort of check what you've done. Okay. So let's have a look. So let's have a look at what Sue said. So she said previously 0.2 of the books are returned late, and she's made some changes. And all she wants to know is about, has the proportion changed? It doesn't say has it increased or has it decreased. You see, ideally you'd want the number of books returned late decrease, wouldn't you? Well, it just says that she just wants to know, have they changed? Right, so this is different to what you've been doing before. And then so she said so she's going to look at 30 books. So let's look at, so we need to state some hypotheses. Now, it's slightly different. We're going to look at a critical region. But I mentioned a two-tailed test. Now, this was what Sue's question was. And then we got some other bits. We'll look at those in a minute, okay? So let's start off and actually think about, right, so what have we got? So first of all, X is the number of books in this sample returned late. So we just need to summarize. There's lots of information, lots of words here. It becomes quite confusing. So let's just extract what's actually important there. All right. Now we can also say it's binomial, isn't it? Because the book's either returned late or it's not returned late. So, and we've got, this is done 30 times. Now when we start to summarize like this, you can really just pull out what's important. And then we've got some p-value. And that's really what we're investigating. Remember, we want to know, is it 0.2 or is it not 0.2? So now let's start talking about what happens about this being a two-tailed test. Okay, so what do we know first of all? Now this is what Sue needs to work with, okay? So our hypotheses, our null hypotheses first, is that p is equal to 0.2. So the alternative is that it's not equal to 0.2. And now it doesn't actually state in this question, it doesn't actually state in here the significance level to use. So I'm going to decide on what it is. Now exam questions, it would, virtually all the time, it would say what significance level to use. Right? It's very, very unusual that it won't say that. But as this doesn't say, I'm going to say it's 5%. So now we need to think about, how does this change things?
I think I got it, Mr. Skeen. So Two-tailed just means you need to half the significance level. And to recognise two-tailed is it just says it's changed. So one-tailed would say something is increased or decreased. So you basically just work with the significance level that you're given for one-tailed. Is that right, Mr. Skeen?
Thank you, Sue. Yes, that's right. Yeah, she's got it. What actually happens is that this 5% needs to be split. So if it's one-tailed, as you've been looking at previously, then we would just work with a 5% level of significance. But this is two-tailed. So because it's two-tailed, that 5% effectively needs to be split from the lower part, the lower tail, and the upper tail. So effectively, we're going to be looking at 2.5% on each side. So that's kind of what our sort of, if you like, the significance level of each side. Just to remind ourselves as well, as a decimal, it's that figure there. So again, let's summarise where we are. Let's have a look. What are we really looking for? Now, remember this question referred to critical region. Okay, so the critical region is where we would be maybe rejecting the null hypothesis and actually think that it has changed. So let's have a look. So first of all, we're interested in, so what x value would give us, so a cumulative x value would give us a value of less than or equal 0.025, and likewise, what value more than or equal to would give us a value still less than 0.025. So this is like the lower end, and this is the upper end of what we're looking at. So all you need to do at this stage is to go and work out a value. So you can do this on your calculator. You could do this, you could look in your, if you look in your formula book, there are tables of values. You could go and work them all out individually if you really want to. All right, so, but this is kind of, that's like more of the easy bit. So I've got some bits here, look. I've already worked some bits out for us, okay? So let's have a look at the lower end first of all. So when x is less than or equal to 0, yep, that's below 0.025, yep, so that's great. What about this? How far up can we go? How close can we get? So x being less than or equal to 1, so is that less than 0.025? Yes, it is. And then this one, no, it's not. Okay, so that's our first point of call. That's like the lower part of the tail. And now let's look at the upper part of the tail. Now, if you're like me, I have to be honest, the upper part of the tail is the bit that I always that's the bit I need to think about. And you need to say this to yourself. You need to say x being more than or equal to a number. Is that going to be less than our figure just here? All right. Now, with a bit of practice, you can actually spot this quite quickly. But if you're a little bit unsure, do this here. Right? Do this. So when x is more than or equal to 10, remember that's 1 minus all the stuff that's below it. So if you work that out, so that's 1 minus this figure. So that's going to be equal to 0.0611. So is that below 0.025? No, it's not. So we need to go a little bit further. So we'll look at this one. So just do exactly the same. Now, annoyingly, when you work this one out, it's actually really close. But it's a little bit over. Right? Is that below 0.025? Annoyingly, it's not. So therefore, we're not going to include it. Now, if I do the next one, that's going to be equal to 0.095. So it's that one. So 12 is the significant part, right? The critical area. Now, I have seen questions on this, they're just being a bit awkward, and they have said things like, make your value as close as you can to 0.025. So if that was the case, then that would be the answer. I have no information about that, so I'm not going to do that. But just look out for that little bit of wording sometimes. I really don't like it when it pops up, but I have seen that on the odd question before, and you know, I kind of feel it's just there to try and catch you out. So let's actually write down, so what does this really mean? So let's have a look. What does it really mean? So our critical region. So our lower tail was 1 and everything below 1, and our upper tail was 12 and everything beyond 12. Right, so let's just work on from here. What was the rest of the question? It said find the actual significance level of your critical region. So let's have a little look. Now this, when people are asked about this, they get a little bit confused, but actually it's really easy. And all you need to do is, so what was x is less than or equal to 1? So we've already got that. And what is x is more than or equal to 12? There you go. Now remember that other question, I've seen it occasionally, where it says make it as close as you can to 0.025. Then that would be 11, and then you would use that associated value there. Right? Like I said, I don't think that's a fair question, but I have seen it. And then you just add those up. So it kind of looks kind of quite confusing, but that's all you actually need to do. Okay, and then the last bit was, well, okay, what actually happened? So I think you'll find that it talks about 4 books. So 4 books is not in the critical region. Don't leave it there. Right? Don't leave it there. We need to say, what does that actually mean? And we need to make a conclusion. Now this is the bit. Actually, you know, there's always quite a lot of marks on this, but people leave it out. And all you've got to do is this. Okay, so we're going to write some sort of conclusion. So first of all, let's make reference to the null hypotheses. Okay, so there's no evidence there that the null hypothesis is wrong. So no evidence to reject the null hypotheses. And now let's also just back that up a little bit more and just say, what does this really mean in the context of the question? Again, lots of people leave this out. Now you can virtually copy the question on this. Now there's no evidence to reject the null hypotheses. So remember the question. Now I've virtually copied this. So there's no evidence that the proportion of books returned late has changed. I basically just copied this, what the question was. So, and sorry, but Sue, she's wrong in her belief, okay, in terms of what our question actually says. All right, so don't forget about this bit just here. Remember, one-tailed, you're looking for an increase or a decrease. Two-tailed, it just says it's changed. But if it's two-tailed, you need to make sure that you actually look at the significance level and split that significance level on either side.
Mr. Skeen, could I do example 2? So the null hypothesis would be that P is 0.1, and then it says that campaigners claim that the proportion of residents who are against the plan has increased. So that means the alternative is P is more than 0.1. So therefore that's one-tailed test. Is that right, Mr. Skeen?
Right, thank you, Sue. Yeah, you're right. So let's just summarise what she's just said. So, okay, she did mention, so number of residents in the sample against the plan. So remember, here's a question. So residents of a town are being asked about a plan to build a wind farm in the area. So past records show that 10% of residents are against the plan. Campaigners claim that the proportion of residents who are against the plan has, and that's what Sue's just highlighted for us, has increased, and then there were 50 residents surveyed. So let's summarise. So what have we got? So we've got the null hypotheses, got alternative hypotheses. It's increased. It's one-tailed. Now it's quite a tight significance level here. It says use 1% significance level. So that's actually referring to, if that is a decimal, is 0.01. Now this question makes no reference to working out the critical values, or our critical region. So I don't need to do that. You could do it and then see if your number is in the critical region. We know 6 are against the plan. So we want to know whether that's actually increased. So we could do it that way, but it's actually not really necessary. All we really need to do is to find out this value. Okay, because it says of the sampled residents, so we'll just move that up so you can actually see it, 6 are against the plan, so 6 out of the 50. So we're talking about it being increasing. So all we need to work out is this. How can we work out this value? And then we're just comparing it to here. Is it smaller than 0.01? If it was smaller, then that would be quite small working under these conditions. So therefore we would suspect that the p-value has actually increased. Here, it's clearly not, right? It's miles off. So all we need to do there, just make a comment. It's clearly more. And now, what does it mean? Remember, the conclusion is vital. All right? And all you need to do, again, is make a reference to the null hypotheses. So in this case, again, there's no evidence to reject it. So write it down. Okay? No evidence to reject null hypotheses. Don't know what I was thinking there. And then put it into real terms. And now remember, this bit basically comes from just copying the question. There is no evidence that the proportion of residents, so you'll see this, look, there is no evidence that the proportion of residents who are against the plan has increased. You see, look, I've just copied it from up there, but you need to reference it. All right. And then, so obviously if it was the other way around and this was below 0.01, then we would say there is some evidence to suggest this. Okay? Right, so hopefully found those useful. You're going to try some more questions. Thank you, Sue, for your help with this. Right, and I'll leave you to get on with some questions.